Hi, everyone. Welcome back to another episode of the PETHS Alumni Network podcast. I'm your host, Nathan, and today we are joined by none other than Mr. Jonathan. Hi, how are you doing?
I'm doing great. Thanks for having me on.
No problem. So to give you a bit of background, Jonathan, you graduated in 2018. You're now studying mechatronics engineering at McMaster University. You were very involved in Trubotics, Relay for Life. You did the morning announcements, which we talked about. I'm missing a few. Band, you were in band for a year. Anything else?
I did DECA for a few years, but
right.
It wasn't my passion, so.
Okay, yeah. So I guess we'll work, back in your high school years, obviously you were involved in a lot of extracurriculars. What are some standout moments for you?
Standout moments for me, okay. Standout moments for me were winning the first competition as the first school from Markham in the VEX robotics competition in the provincials. We were the first team to do it in the wire DSB. And that was a very proud moment for me and my team members because we basically built that team from the ground up. On top of that was hitting the milestone of $50,000 raised for cancer for Relay for Life, which was another kind of example of the kinds of things that we did. And also one of the other standout moments was when I was doing Trubotics and it was a winter day. No one had to show up. It was the week before our competition. The whole team did. And we really pulled together to get it done.
So going back to Trubotics, what does like a competition look like? What are you feeling? What are you thinking? How does the competition actually work?
Oh, well, they keep you busy. They keep you really busy. The way that it works is that you spend the whole year developing your robot. They give you what the competition is going to be at the start. It's always a different problem. Sometimes it's stacking cones. Sometimes it's rolling balls. And you spend the whole year designing and building your robot and testing it out, choosing your drivers, optimizing it. And then what happens is they get all the teams together into one school and they host kind of a traditional trip, kind of tournament style of competition. And it really doesn't hit you until you're on the field itself that, it's showtime.
Yeah.
Because you're so busy, you're doing so much, you're running around making sure this works, that you don't even have time to realize that now it's actually time to go. And but then your skill kicks in, your intuition kicks in, and you do the best that you can. But afterwards, you feel so tired. I think this is the same with everyone in this competition. You feel so tired. But the thing that you notice the most, your team is there, and your team is always there to support you, which is a really big deal.
Right. So one question I have is, if there's only one, driver, what's everyone else kind of doing? I would feel kind of nervous knowing it was out of my hands. How does that kind of look for you?
Oh yeah. It's a bit rough sometimes if you're not the driver because you put all your effort into this baby, into this robot, and suddenly you're giving it to somebody who you know them, but you don't know what they're going to do.
Right.
And so what they often do is they kind of sit on the sides and they kind of pray. They pray or they rock back and forth and they hope. Or you can build them into the actual driving team. You can have two drivers. Or you can have people feeding you information. But if you're not directly involved in the driving, it's very tense. It's very nail biting, right? It's like, you're the coach of a player and you don't know what's going to happen. It's the first time going out, but it all works out. And afterwards, you go and celebrate.
Yeah. Are you competing on speed purely? Is that?
It depends on the year. Okay. So sometimes it's speed, sometimes it's accuracy. Sometimes it's the number of things you can stack or get in a goal. It changes every year. If anyone's interested, the competition is called VEX Robotics, and they have divisions in elementary, high school, and also in university. So you can keep doing it throughout.
Who is the teacher supervisor for Trubotics?
Jennifer Petkovic, Miss Petkovic.
Okay, yeah, she's a tech teacher, yeah.
Yeah, she is a tech teacher. She was the one who was willing to actually do it. We stuffed everything in her office. Everything was pushed into the corners and all that. It was a good time.
What's one big thing that you learned, running the Trubotics team and competing?
You're only as good as your weakest link. It sounds kind of cliche, but it is true. It doesn't matter what it is, but when it comes to projects like this, the whole thing can work except for one part. If that part doesn't work, you have nothing. You've got to be thorough. You have to be thorough. You don't necessarily have to be perfect, but you have to be thorough to make sure everything actually does work and put in the time and effort to ensure it happens, which is really, really important in engineering. it really helped to carry me throughout a lot of things that I did later on.
Right. Do you have an example of like a problem or something that didn't go right and like how you had to deal with it?
Oh, absolutely. So in the year that we went to provincials, we had the whole robot was set up to be working with absolutely no problem. We optimized the way it lifted things, the way it could stack things, the speed. But there was one problem, that there was a motor that was constantly burning out, and we didn't know why. Turns out it was because there was too much load on it, and it kind of failed after a while. But that motor was one of the ones that powered the lifting arm, and it failed. We didn't know what to do. We didn't have any spare, right? We didn't have anything to replace it. And without it, it just wouldn't work. Now, you could replace that with anything. Yeah. Anything on that robot could have stopped working, and then it would have been the same situation. But it really kind of ground us down. I remember Andy Chang, who was a valedictorian of our year, really tried to figure out how to make it work. He spent hours on it, but it didn't. So what we had to do was we had to basically pull it apart, and we thought to have something is better than nothing at all, right? And so instead of having it something you can lift up and down, we had it so it can basically push the goal in a certain way that we wanted it. And it would only score about half the points we wanted to, but that was better than nothing, and we still went to provincials.
Nice. Do you know where the actual robot is right now?
Oh, probably broken down for scrap parts, honestly. The material is pretty expensive. Yeah. So every team recycles it every year. We also try to be as eco-friendly as possible. So we try not to buy as many things, save some money as well. And so it's probably, the good news is probably in all of the robots right now is a little bit of our original one in it.
If I had to ask, what was the budget for the robot that year?
$100.
$100? Okay. Yeah.
That's it.
Okay, that's pretty impressive then. How big was it? Like,
oh, it was pretty big. So for me, for context, this is about a foot, right? Okay. And so it was 2 feet by 2 feet. So, and it weighed something like 35 pounds. 35 pounds. Okay. It was not nothing. It was not nothing. We had spent a lot of time and effort to do it. And we pulled a lot of parts together to make it work. And that thing kept breaking on the way to the competition because the car kept bouncing it around.
So presumably you've always been into, building like this kind of, machines and, mechatronics you've gone into. Where would you say like this passion started for you?
Well, I was very lucky. My parents both are, well, one's from a technical background. My dad's an engineer and my mom was a very high-powered businesswoman. So they both were very good at trying to get me and my brother interested in science and technology without being overbearing. Right. So what they did was they brought us to, they started us off with Lego, they started all with their things, but they exposed to a lot of different things. I discovered my passion for machines and for robots at a relatively young age. I was always fascinated with airplanes. I was the why kid. Why is that? Then why is that? Then why and why and why? And as far back as I can remember, I always want to know the way that the things that we use worked. And I wanted to know, how can I change them? My dad told me that I used to stuff 5 or 6 CDs into the CD player and it would break. But yeah, so that started where it started, but it really took off, I think, in 11th grade. Because in 11th grade was when I met some of the people who I did physics class with, my clubs with, and I discovered that working with people in a technical environment is so rewarding. So that's when I was solid in grade 11 to the point where I said, I want to go be an engineer.
So what did you really like aspire to from like, how has your aspiration kind of changed? Because a lot of the times, I'm not saying you specifically, but people have idealistic, visions about a certain field. How has your like vision of what you want to do changed in that time?
Oh yeah, absolutely. It's huge. So first of all, I totally agree with what you're saying. We're forced to make this decision about our careers with no information. We rarely visit the campuses. We have nothing to rely on other than the advertising material from the universities themselves. And then we have to choose what we're going to do for the rest of our lives. It's a really difficult choice. For me, I was relatively lucky. But that being said, I still got hit with that. So idealistically, at the start, what I thought I was going to do was I thought I was going to be the kind of guy that loved mechanical stuff. I wanted to pull things apart, automotive, airplanes, ships, rockets, and everything like that. Then I learned that I really don't like math. And one thing that a lot of people don't realize, surprisingly, is engineering is a lot of math. And not even just adding, subtracting. It's really strange math too, and it goes down a lot of rabbit holes. And a lot of engineering too isn't just doing the technical work of Mark Rober, where you build this kind of thing and you make a device. A lot of it is writing things down, documenting things, making sure you do things clean, safety standards, right? There's a lot of stuff alongside the flashy things that we see. And that stuff, the supporting things, the boring kind of cleanup work is 80% of the work. 20% is the flashy cool stuff, right? And that's what I realized, that 80% of it was documentation, meetings, budgeting, all the different kinds of stuff, talking to the marketing department, talking to the accounting department, right? And then you can get to the rest of the work. And turns out I love that too. Maybe not as much as the technical part, but I'm perfectly okay doing it. And I taught myself to love the process as a whole.
So you kind of touched on it, but is there anything else that kind of like shocked you, like when you went into post-secondary about the field?
Oh, shocked me. Everyone around you is a genius, but they're not really. I mean that kind of, not really. Everyone around you thinks they're a genius. Some are, some really, really are. There are mind-blowingly intelligent people that go into engineering. But when you sit down in your first class in engineering, you think to yourself, I had a 96 average. I'm gonna be fine. The guy next to you, 97. The girl next to you, 99. Every single one of you has seen success throughout high school. And one thing that really shocked me because of that, and shocked everyone, is you have to get used to failing. Failure is such an important part of the engineering process. It's not even failing in terms of doing your testing this prototype doesn't work, not like that. Failing to understand things, failing to learn this, failing to get this, and figuring out how to overcome that is a huge important step, and one that is really difficult for a lot of engineers to handle because they were top of their class.
Yeah, I think you hit the nail on the head. A lot of successful people come from PET, and PET's obviously very academically strong. So a lot of people, like you mentioned, will have a 99, they'll have a 98, they've been top of their class, and I think it's important to be able to use your own strengths and realize how smart you are, but at the same time not be defeated by when you see someone who might be just as successful as you, right?
Oh, absolutely. I think you're also on the money, because we know that we're smart. We got into the schools that we got because they value our intelligence. Obviously, if you're a post-secondary student, you're in the tiniest elite in terms of intelligence in the world. And that by and of itself cannot change. You are smart. That's just how it is. But smart people also have to deal with the reality that they can be wrong and they can fail, and that they might have to work. They might not be as good at some things compared to other people, but then that's okay. That doesn't make you worth any less. It's just that it's a part of life, and we learn to deal with it, and we get stronger because of it.
Perfect. I think you nailed on the head. We were talking off camera a little bit about stereotypes about engineers and how a lot of them think that they're the smartest people out there, but a lot of them are. Like, I'll say I met a lot of really smart engineers, but at the same time, it can't be the fact that 100% of engineers are the smartest people in the world. Like, I'm not trying to diss engineers. That's not what we're trying to do here, but I think we talked about it a little bit, right?
Oh, absolutely. But the unfortunate reality is we really don't know how to measure intelligence yet, right? That we have tests, we have marks, but I know plenty of people who ace every single test but can't figure out what to do in a high pressure situation. I know plenty of people who basically barely skimmed through their courses, who went on to be the most successful people around, because we just don't have the tools to be able to measure intelligence and measure proficiency. We do our best, of course, but to associate your success, if you want to call it that, with your value as a person, I think is something that's very detrimental. You have to understand that a person's value is not necessarily their marks, is not necessarily what they can accomplish, their skills, even though we're really taught that growing up. We are, especially in a place like PET. Everyone competes. Oh, I slept 2 hours last night, right? I slept 2 hours last night. I got this mark, I got this mark. I got an 80, I failed. It's a disaster. To break free from that and to realize that learning and that your worth is not associated in any way with your marks or your intelligence or your skills, that you yourself are worth everything you need to be without that is so important, especially for smart people, especially for people who can do what they do, because the moment they deal with failure, then it's a culture shock, right? Everyone learns it eventually. It just takes some people longer than others.
What do you think is like a trait that you think really does well and something that people should strive towards being?
I could talk about anything with that 100 billion other interviewers say for, oh, work on your resume, oh, do your networking, whatever. I'm not going to talk about that. I'm going to talk about something I think is more fundamental. Empathy. Empathy is probably the most important aspect a person can have ever. It's probably not even a close competition, because to be able to understand how other people feel and to realize that everyone around you is dealing with the same stuff that you do, and to be able to put yourself in other people's shoes is such a useful skill, because we live in a world of other people. Regardless of what other computer science and engineering people think, you can't live in a basement and talk to nobody for the rest of your life. You have to work with other people, and to recognize that they're just as human as you, they're just as fallible as you, that they also deserve the kind of grace and the kind of second chances that we want. It's incredibly important. And we become better people because we become more patient. We become more compassionate. We become more positive because of it. There's an old saying, if you take too long, please tell me, but it's, we judge ourselves by our intentions, and we judge others by their actions, right? If we're having a bad day and then we cut someone off in traffic, oh, I'm having a bad day, I'm not a bad person. If someone cuts you off in traffic, they're awful, they're terrible. But in reality, we're all dealing with stuff. And to be able to extend that beyond yourself is such an important thing to do, not just for school, even though it is incredibly important. It's important for the rest of life.
Right. No, I think you hit it right on the head. I think a lot of people don't necessarily realize that. And, it makes me think of like self-serving bias, like you attribute, your own successes to your own traits. You say, I'm smart, I got a good mark, I did this. But then if someone else gets a good mark, a lot of people naturally, they'll be like, oh, they got lucky, or, the test was easier, things like that, So I think it's important to really, obviously, keep your grades up, do well in school, but, have the right mindset, be a good person. Obviously, those two things need to go together, right?
Yeah, of course. I mean, obviously, it just also comes with a caveat that says don't be a pushover, right? You still have to fight for the things that are important to you. But at the same time, you can do that while being empathetic, while being compassionate, while doing all the things that make life more, make the world a nicer place and you a nicer person, while also fighting for the things that you believe in.
I think you hit it right in the head. So I got another question for you. What were some of these values, how did it relate to where you ended up going to school? Like, did you, look at McMaster and say, what, I think this is a great community? Like, what were some considerations that you had when you were applying to schools?
So when I was applying to schools, this was when the whole mark inflation stuff started to get pretty bad. No one really talks about it, but mark inflation is such an awful problem in secondary school. But this is when it first started being a problem, and schools didn't really know how to deal with that. And so I think I was one of the first years where the Waterloo engineering had a minimum 95% average to enter. And so I got rejected from a few, so I didn't manage to go to Waterloo. I think that I got into U of T, UT Mississauga, UT Scarborough. I didn't get into U of T St. George. So I had the choice between Queen's, Ryerson, U of T, the other campuses, and McMaster. And one of the things I liked about McMaster was that they have very few hangups. They're very down to earth. I'm going to tell you something right now that a lot of other McMaster students aren't going to appreciate. Mac students aren't the brightest in the world. I'm not. I'm one of them. I'm not necessarily the cream of the crop. But what they are is that they don't have necessarily superiority complex as much as other ones. The whole environment is very nurturing. McMaster engineering as a whole is a very nurturing environment. At U of T, at U Waterloo, at Queen's, Ryerson, the prof will make you buy a textbook that's $200 that they wrote themselves. It's only that thick so they can make more cash. That never happens at Mac. I think I've only bought one textbook at McMaster because all the professors know that we're dealing with the same stuff. Another reason why I chose McMaster on top of the faculty being very nurturing was because of the fact it had the widest range in terms of engineering that I could find. And one of the things about McMaster, do you know that McMaster has a nuclear reactor on site?
I did not know that.
There's a nuclear reactor on site. So if you want to study nuclear energy, this is the best place to do it. And not only that, McMaster has the best children's hospital, basically in Ontario, and McMaster Children's Hospital. And so if you want to study anything related to healthcare, pediatrics, biomedical stuff, which I was relatively interested in, you come here. But the main reason, honestly, why I chose Mac over anything else was because of their first year program design. I told myself, I don't know exactly what kind of engineering I want to go into until I try out a few. And McMaster has a general first year engineering. So you go through a big project called 1P13 and you incorporates every single aspect of the engineering process and involves a lot of the different kinds of things that you would do in many, many fields. And so what you can do is you can look at that and say, I hate this. I love this. This is awful and this is disgusting. I never want to see that again. And so what it helped me to do is help to shrink the number of things I wanted to do down into basically software engineering, mechatronics engineering, engineering physics, mechanical, electrical, instead of civil, chemical, biomedical. I didn't want to do that. I didn't like those courses. That was why I chose McMaster, because it actually allowed me to be in an engineering educational environment without making me choose exactly which field I wanted to go into yet.
Right. And I think we talked a little bit off camera about, I'm in business, so I have no idea how, this stuff works, but you mentioned mechatronics is like a fusion of all these things and it incorporates different parts so that you have a more holistic view of engineering. Can you tell us a little bit more about, what mechatronics actually is?
Holistic is a good way to put it. And the reason is mechatronics is one of the most application central engineering programs. You have traditional engineering like civil, mechanical, where you learn a lot of practical things about a wide range of topics. And what you do later on is then when you go into the industry, you might specialize in a certain kind of thing. Mechatronics is a little bit different. It's very focused on a specific kind of engineering versus teaching you a subject and teaching you related things to that subject. What they try and tell you to do and teach you is how to deal with mechatronics systems. And there's a similar kind of program in Waterloo called systems engineering. And the idea of that is to figure out how a lot of different things work together. And mechatronics is similar. You take mechanical aspects of the things that we use, combine that with the software aspects of the things that we use, and the control aspects and the electronics. Now, what is a mechatronics system? Everything is a mechatronic system if you want the dumb answer. But in reality, it's things like your car. It's anything which combines software, mechanical stuff, control theory, which is how you actually understand where you are and what you're doing and how to guide your machine to do exactly what it wants to do, and electronics. Your phone, your car, an airplane, a microphone, a laptop, anything like that is a mechatronic system. And what they teach us to do is they teach us how to deal with the intersections of these things, how to take the mechanical component of, let's say, a drone's rotors, and how do you program the motor? And not only how do you program the motor, how do you program it in a way that it controls itself perfectly with the minimal number of electronics to do so? It's focused on optimizing for all four of these kinds of things. And you can see how that's useful, right? One of the problems a lot of engineers face is something called cross-domain boundaries. It's a technical term, but it's pretty simple. What it means is that if you're a mechanical engineer, you know that part. If you're an electrical engineer, you know that part. That aspect in the middle, it's really hard for those people to cross. Mechatronics aims to be able to look as a system as a whole and optimize each part to work with each other perfectly.
Mm-hmm.
You can, typically speaking, go into four fields, I believe: automotive, energy, aerospace, and there's one more, I believe. It's AVE, vehicular related. I think it's defense, but
Mm-hmm.
I'll check. I'll check for you. But
You mentioned that you were in co-op, right? That's another big reason
yes.
that you chose McMaster. What have those experiences been like?
So co-op has been wonderful.
Mm-hmm.
So how much do you know about the co-op program?
Not very much. Tell us
Would you like
everything.
me to give a short explanation?
Tell us everything.
Okay. So the co-op program at McMaster anyways is set up so it gives you the opportunity to get your first job. One of the hardest parts that everyone knows is after graduating is finding your first job. You have no experience, you have nothing that an employer wants you to do, you have a degree, and you don't really have much of an idea of what's going to happen, so you're a little bit of a risk as a new grad. The co-op program aims to deal with a lot of those problems and also teach you a few skills. So what happens is that if you're enrolled in a co-op program, your program designation isn't just blank engineering. So it's not like civil engineering, it's civil engineering co-op. So you get an additional part to your degree that shows you actually did co-op. And if you want that, you have to complete a certain number of co-op terms. And co-op terms are these blocks of work time, 4-month, 8-month, 12-month, 16-month, that you look for and then you apply for. And it's basically work. It's work. It's a job. It's, at the end of the day, it's and the reason why employers like it is because the government pays for it. Do you know that?
No,
the
I didn't know
government
that.
pays for co-op salary. If you go to co-op, your company pays no money, and that's why companies love hiring co-op students. It's free labor. And what it allows us to do is, as engineers, is we finish a few years of school, okay? And then we go onto our university job search website and go apply for jobs, apply for jobs, apply for jobs. It teaches you about what the job application process is like, how dehumanizing it is, how you have to apply to 300 different things and get 2 responses. It teaches you that because that's just how job hunting is. And once you do get a job, it teaches you how to be professional, because we can take as many communication courses as we want, as many ethics courses as we want, but until you're on the ground and able to see what reality is like in a real workplace, you won't know how that functions. And it's also nice to get paid, right? Oftentimes, a lot of engineers graduate with no student debt because their co-op pays for the debt that they accrued over their years. And what happens is you leave with the knowledge of what it's like to work in a technical environment, because typically speaking, if you're getting engineering co-op, you're working in engineering. The ability to say that you now have had a first job and that you're employable, because that's a big deal. You can actually hold a job. You get a network of people who you've worked with and who understand you, who you can now go back to, possibly a return offer. Yeah, chances are if you're good, they want you to come back if you're really, really good. And not only that, you get letters of recommendation, you get things to put on your resume. You basically start to build your career in an environment which is safer and shorter term, which is great for you, because if you hate it, you just stop after a while. And if the company hates you, you're gone. So it's really not a big deal to either of you, and it's a wonderful arrangement. So by the time that you graduate, you actually have work experience. And I can't tell you how amazing it has been for my skills. My co-ops, first one was done at a company called CGI. We did a lot of IT consulting for one of Canada's biggest telecom companies. And I got to work with the really top level C-suite executives, the CTO, CEO of those telecom companies. I got to work basically directly with them. It was great exposure. And the second co-op I did was doing machine learning for a healthcare research company. And that opened up my horizons about what machine learning is like, and it helped to build my skills for it. And now it started my passion for machine learning and mechatronics combined together.
I know it's a broad question. Where do you kind of see, I know machine learning is like a huge thing right now. What are your like predictions and what do you see on the horizon?
I have a little bit of a controversial look when it comes to machine learning. There's a concept in technology called an S-curve. where you start at the very beginning of a technology and then you get a huge development, and then it tapers out at the top. It's like smartphones. In 2007, there was a little bit, and then the iPhone came out, then all Samsung phones came out, and now they're all kind of the same, right? Technology development hasn't really gone that much. Without a future breakthrough, I believe AI will be like that. Because we saw the huge, we're still probably in the area where we're going up, but we're starting to level out. The abilities that we have right now are very advanced and they're very good at specific things, but there's other things that they're really not good at. Did you know that ChatGPT is basically like autocorrect on your phone, but on steroids? That's what it basically is. If you really dig down to it, it's just autocorrect, but very, very good autocorrect. And there's a lot of other challenges we have to go over. These huge language learning models require 500,000 gallons of water every month to cool down their servers, right? And so the technology is still maturing, but it is maturing. I think we're reaching a step where we see a lot of the applications start to come out and where it stabilizes until another breakthrough comes along. Then something big is going to happen. And one of the things about AI and machine learning that a lot of people who aren't necessarily in a technical field may find a little bit scary or daunting is that machine learning is getting really good at understanding human language and being able to talk back to us. And because we're humans, we associate language with intelligence, right? But what I can tell you now, as a machine learning engineer, machine learning is just math, man. It's just a long string of math that you plug something in and it comes back out. It's as intelligent as your calculator. That's about it's just designed in such a wonderful and specific way that it becomes very good at a very individual problem. Sorry, I'm just finishing this up. Yeah, and it's designed in a way that is that's meant for a very specific problem. It's very good at solving very specific problems. However, the future of it kind of taking over everything is, I think, a little bit overstated, but it will be very useful. And a lot of people should be concerned about their job security. Really. Did you know 2/3 of Americans say that AI could do their job?
I'm not surprised, no.
Yeah, because if you can write, if your job, secretaries won't exist anymore. There's no point. There's really no point because everything a secretary can do, machine learning can do. But for example, a business, like something that you do, AI will not replace. It will not replace.
Maybe some aspects.
Maybe some. It might be able to write things for you. It might be able to forecast things for you, but it can't make the decisions to say, what is a good business? What should I invest in, right? These kinds of what we call symbolic logic, these kinds of thinking, real thinking, hard for it to do. That's a very long answer, but I hope it's satisfying.
Well, you've seen those like self-driving cars, like self-driving taxis. There's grocery stores without people in it. There's like McDonald's that are by robots, so it's crazy. We'll have to see.
Oh yeah, absolutely. It's definitely a quantum change in society, and you will see them everywhere. But I think that the nature, the style that it is right now is going to stay relatively the same into the coming future, anyways.
Okay, that's an interesting point. We'll start wrapping up now. Do you have a favorite high school class or teacher that you want to shout out?
My favorite teacher. He's not here anymore. He moved on.
Okay.
Mr. Wong in math class.
Mr. Ivan Wong.
Mr. Ivan Wong.
Yes. No, I think he did move on, but I was fortunate enough to have him as my teacher, and I
love Ivan Wong. He was the guy who actually, he's so funny in a way that he doesn't understand is funny. But that in terms of that kind of, but maybe Ivan Wong's one of them. Another one is the whole physics department. I've never met better physics teachers than Mr. Baker, Mr. McCumber, and Dr. Jeff. Never in my life.
I've had them,
Yeah, there's no way that I've never seen someone be able to teach fundamental physics that much. They could be a bit nicer in the way that they mark, but that's a different story. Other than that, I think one of the teachers that really made a difference to me that I really looked up to was Mr. Davidson in the history.
Mr. Davidson, yeah. We've heard his name,
yeah, he was wonderful because he really encouraged us to think about the things we were learning, not just to absorb the textbook. He really goes, what does indigeneity mean? What impact does famine have on a people? What is that? Debate amongst yourselves, right? And to encourage that kind of thinking was something that I found very special.
Yeah, no, those are all fan favorites for sure. We've heard their names thrown around a few times. And what are some aspirations that you have, professionally? It can be in anything that, if we were to come back to you 10 years from now, what would you want to have accomplished?
Nathan, I want to change the world. Okay.
Okay.
I want to change the world. And I think I can do it. And I don't mean this in terms of ego saying I'm better than anyone else, but I think there's a lot of opportunity out there. And I want to make a difference that impacts everybody. It could be making cell phone plans 2% cheaper. It could be making food grow a little bit faster. It doesn't matter. But I want to do something that actually helps people, real people, do real things. And I think I can do it. It doesn't matter what it is. And I want to use my technical skill and my ability to talk to people to organize those things together, to maybe lead a small team of talented engineers or analysts or business people or something to make a difference in the world, a positive difference in the world. Yeah. That is my goal. Doesn't matter.
Maybe we can have some PET alumni, help you out.
Yeah.
They can network with them. Yeah. Okay. Second last question. We're looking for, song recommendations. What's your go-to song right now? We're building up a playlist.
A go-to song? My go-to song right now? Yeah. Agora Hills, Doja Cat.
Okay, that's a good one. We've heard a lot of like that genre, like a lot of like.
You want a different genre? You want a different genre?
No. Well, do you have any others?
I do have a different genre.
We're interested now.
This genre is a little bit more niche, but Put the Money in the Bag by Miles. Have you heard of that?
No, I haven't.
Miles is an experimental rapper, kind of,
interesting,
who's made really unique music. And Put the Money in the Bag by Miles. Give it a listen. Okay. Just search it on YouTube. Give it a try.
Okay. And very last question. Do you have any fellow PET alumni that you'd like to see on this podcast?
Any fellow PET alumni? Tinson Lee.
Yes. Okay. Yeah, we've heard his name thrown around before. Yeah.
Okay. Tinson Lee's one of them. Andy Chang.
I think he also went to Ivy.
Yes, he also went to Ivy. That's right.
Ivy grad. Yeah.
Suad Juman Yassin. Have you heard of her?
No.
She is one of the most intelligent mathematicians out there, and an incredibly nice person. And you want to hear from her as well. Other people who you'd find interesting in my year, anyways. Or maybe not in my year, 2 years older than me, in the year of 2016, Grace Shan. She's absolutely crazy. And if she's listening to this, I think you are crazy, Grace. All right, I really do. But she's incredibly interesting, and she's a brilliant. She has degrees in engineering and in philosophy, and she's got a lot to do with that. Other than that, yeah, I think start there. Okay,
they've been put on notice. We're gonna call them out. They've been called out. We'll reach out to them. Anyways, thank you so much for your time. We had a great talk about, empathy and, almost like imposter syndrome, going to such an accomplished program and being from such a strong school. I think it's something that a lot of kids can relate to some degree. Do you have any closing remarks?
Sorry?
Do you have any closing remarks?
The final thing I want to say is to every single high school student out there, there's a few things. So try not to take things personally, right? Which is, you meet a lot of people who go like, yo, this prof is trying to screw me, bro. He hates us. It's never like that. It's never like that. They're just people. Also, it doesn't get easier. You get better at it. And you won't believe me, but it's true. They won't believe it. It's hard, but you get better at time management, organizing, intelligence, thinking. It becomes as easy as walking. And not only that, once you get into university, do whatever you want. There's no right way to live. There's no right way to be a university student. No one can tell you exactly what you should do it. Do whatever you want, explore whatever you want. Don't explore whatever you want. It's
within the law, that is.
Exactly. You are an adult, you will be an adult, and it's your chance to grow.
Yeah, I mean, especially you go to a party school like Western, McMaster, I don't know. McMaster, hey, we don't know if they're a party school as much.
Hey, I got my fair share of stories, which I'm not allowed to tell you, right? Yeah, I can't tell you those, but yeah, but it was great to be on, Nathan. I really do appreciate it.
Yeah, thank you so much. So, you actually reached out on Instagram, which I really appreciate, So yeah, if anyone else wants to reach out and share their story, please do. It was great talking to you, and thank you so much, everyone, and thank you, Jonathan.
Likewise. Take care.
See you. Bye, everyone.